let's see if we can extend the path counting brain teaser to 3 dimensions. So let's say that I had a 3 by 3 cube. I'll keep it at 3 by 3 to keep the math from getting too hairy. So let me draw it like that. I won't use the line tool just because, well, maybe I should have. So let's see. The front of the cube looks something like that. That's the front of the cube. And the cube goes backwards like that. Comes down. Goes like that. It's a 3 by 3, like a Rubik's Cube. Yeah, I could have drawn this a little bit better, but I think this will meet our needs. Okay. There you go. 3 by 3 cube. And so our goal is to get from this back left cube, this top corner back left cube, and get to this front bottom right cube. So this is our goal. I'll do it in this yellow. This is our goal right there. And we are allowed to either go forward from any cube. These are our 3 operations, or our 3 movements we can do. We can go forward, or I guess towards the front. We could go down. We could go down. Or we could go to the right. So I can't draw it here. Oh, I could draw it here. We could go from that cube to that cube. So just like the 2-dimensional problem, you're only allowed to make forward progress. You're not allowed to come down here and then go down over here. You're allowed to go down here, then here, but then you're not allowed to go up. So every step you're getting a little bit closer from this back left top cube to this front bottom right cube. And so the same question applies. How many different ways are there to get from there to there? And you can pause it now and try it yourself, because I'm about to explain how to do it. And the first thing, when you try to do it yourself, is to realize that, boy, this is hard to visualize. Even if I had to draw this out, boy, I have to go in and out. I mean, how do I even visualize a 3-dimensional cube like this? And the best way to do it is to separately visualize each of the separate layers. So let's do that. Let's make this the magenta layer up here. We'll call that layer 1. So this is the magenta layer up here. And you'll see what I'm doing in a second. This is the, I don't know, the mauve layer right there. The mauve layer. And then finally I'll do the orange layer. The orange layer is that one right there. What we can do is separately draw each of these layers. So first let's do the magenta layer. So the magenta layer will look like this. And now I'll use things that help. Nope, not like that. I want to use the other tool. The magenta layer. Let me draw some squares in here. It's like that, and like that, and like that, and like that. And then the middle one was the mauve layer. Let me draw that. The mauve layer looks something like that. Remember, it's like you can imagine I'm slicing it and just looking at it from above. That's the idea here, and it's going to help us visualize this problem. So the mauve layer looks something like that. And then finally, the orange layer. Orange layer looks like this. And we're almost ready to actually start doing the problem. Good enough. So just to make sure we understand our visualization, this layer up here, we call that layer 1. That you could put this as box 1. This layer is layer 2. So I'll put a little 2 here. And I don't want to get these confused with the paths and all that, so I'm writing it really small. And this is layer 3, or level 3. And that's right there. And just to make sure you understand, this corner right there, this is our start point. And that's right there. Right? Because this is the whole top. So this is the back left of the top. And our finish point, the bottom right, is right here. So essentially, our problem goes from how many ways to get from there to there to how many ways to get from there to there. So let's just stay within a layer. So how many ways can I get to this point right here? Well, I can only go from this point and go straight in the layer like that. So there's only one way to get there, right? That movement is the exact same movement as this right here. Going from this box to this box. So there's one way to get there. That's the same thing as there. And similarly, I could go there, and I could just go one more step. So there's only one way to get there. And that's like going like there and then there. And by the same logic, I could go 1 to the right here. That's the only way to get there. Or I could go 2 to the right there, and that's the only way to get there. And now, if you watch the two-dimensional path counting brain teaser, you know that there's 2 ways to get here. And the logic is, well, you could draw it out. You could go like that, 1, 2, and that's the same thing as saying 1, 2. Well, it's easier to visualize here. But the general logic was, well, to know how many ways to get to any square, think about the squares that lead to it, and how many ways can I get to those 2 squares, and then sum them up, right? And by the same logic, so there's 2 ways to get here. That's that cell. 3 ways to get here, right? 2 plus 1 is 3. 1 plus 2 is 3. And then 3 plus 3 is 6. So there were 6 ways to get to this cube right there from that one. So this isn't too different from the two-dimensional problem so far. But now it gets interesting. So how many ways, I'll just do it. I did this in yellow, but I should have done it in the color of that layer. How many ways are there to get to this cell right here? This cell is that one right there. Well, I start here, and I can just go straight down, right? There's only one way to be there, but I go straight down, so there's only one way to get there, right? And actually, let's extend it. There's only one way to get here if I'm going straight down. And so there's only one way to get to this cell, too. I'd have to go straight down again. So there's only one way to get there. Hopefully you understand the kind of the way we're visualizing it. This is the bottom row, and there's only one way. You have to go, you go from here straight down to there, straight down to there, and that's the only way to get there. Fair enough. Now, this is where it gets interesting. How many ways are there to get to this cell? Well, in our old example, there was only one way in 2 dimensions to go from this cell. But now we can go from this cell, and we could come from above. And where is above? Above is right there. So now we add this cell to that cell. So 1 plus 1 is, there are 2 ways to get there. How many ways to get to this? You can't even see this is kind of in the back middle of this cube. How many ways to get there? Well, there's 2 ways to come from this direction. And I can also come from above right there. So 2 plus 1 is 3. How many ways to get here? Well, 1 from behind, and then 1 from above. So that's 2. And you see a little bit of symmetry. And how many ways to come here? Well, there's 2 here from going straight forward, right? 2 ways to go that way, and then 1 way to come from above. And that's that one way. Oh no, we're on this cell. So there's, if we are, so we're actually, this is 2, and we're on this cell. So if we want to know how many ways to get to this cell, there's 2 ways to go from there, and then 1 way from above. So that's 3. And now, right here, how many ways to get to this cell? There's 3 ways. I could come from here, or from above. Or from above. So I have the 2 plus 2 plus 2 is 6. Likewise, here, 6, I can come from 6 plus 3 is 9. But I can also come from above, from here. So there's 12 ways to get there. And you can do the same logic. How many ways to get here? Well, within the same row, there are 9 ways, right? 6 plus 3 is 9. And then you can come from above as well. That's 12. And then finally, how many ways to get to this cell right here, which is this one right there? Well, I could come from, there's 12 ways to get here. So I can go all of those ways. 12 ways to come from behind it, so it's 24. And then 6 ways to come from above, right? So 12 plus 12 is 24, plus 6 is 30. I think you're seeing the pattern. So how many ways to get here? Well, it's 1 plus 2, which is 3. How many ways to get here? Well, it's 3 plus 3, which is 6. How many ways to get here? It's 1 way here and 2 from above, so it's 3. How many ways to get here? Well, 3 from behind and 3 from above, that's 6. Here it's 3 plus 3 is 6, but you could also come from above, so 6 again. So that is 12. How many ways to get here? 12 plus 6 is 18, but there's 12 ways to come from above as well. So 18 plus 12 is 30. And by the same logic, there's 18 ways to get here from these 2 cells, but I could also come from above. So that is 30. So how many ways to get to this last cell? Where there's 30 from this direction, 30 ways from there, 30 ways from behind it, that's 60. And then there's another 30 ways to come from above. So there are 90 ways There are 90 ways. I could write that there, but you can't see it. 90 ways to get from that cell over there to this cell over here. And in the last video, I made the analogy to the binomial theorem. And I'll leave you to think about what the three-dimensional analogy is, and I'll throw out a word which is never really mentioned in math class because it's normally too hairy to deal with. Think about formulating a trinomial theorem to help you multiply things like x plus y plus z to the n power. And think about how this cube, or an extension of it, this is a 3 by 3 cube, but imagine if it was or 3 by 3 by 3 cube, but imagine if it was, an n by n cube, then you can start, taking things to arbitrary powers. So I'll leave you to think about this, but I just thought this was a neat visualization problem, which is really not any more difficult than the last one. Actually, before I leave you, I'll leave you with just a general principle, and this is actually really useful for some standardized tests or just logic games. Is if I'm trying to get to this cell, and let's say I have a bunch of other, whoops. I didn't want to do that. Let's say there's a bunch of ways to get here. And it has to have direction. So I won't go into a whole graph theory thing, but it has to have direction, and you can't have cycles. You can't go, because then you could have an infinite ways to get to a certain point. And let's say that there are x ways to get there, y ways to get there, z ways to get there, and I don't know, a ways to get there. I'll cycle through the alphabet. And this is just a subset of the larger graph, right? This graph could have a bunch of just connections. This is just where we are, and these are all of the nodes that connect to this. The general rule that we've learned in the last two brain teasers is you say, okay, how can I get to this node? Well, I can go from here, 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 and I just have to add up. So if I can get from here, there's x ways to come via this node, y ways to come via that node, z ways to come via that node, a ways to come via that node. So the total ways to get to that node is x plus y plus z plus a. And you'll see problems like this if you ever plan on becoming a lawyer. They actually do have problems like this on the LSAT that aren't maybe as complicated as what we did here, but you need to understand this principle. Anyway, hope you enjoyed that.